And my name is Gary Hensley. I'm your session moderator today for the Masonry Current Initiatives. And before we get started, we will hear a word from one of our sponsors, and then we'll have a few housekeeping items to review.
Hi there, I'm Dean Jurek, and welcome to ACM Chemistry's Concrete 101. These are a series of short videos, about 15 minutes or so, that are designed to help you learn a little bit more about what goes on inside your plant.
So, what does go on in that plant with the silos? Let us walk you through some of the fundamentals of concrete technology. Topics like aggregates, mixed designs, cements, pozzolans, admixtures, and even efflorescence. We will get a bit technical, but don't panic. We'll have some famous experts to help us through.
I'm Dr. Emmett Brown, the Diamond Jim Rio here, your gambling man. Roger Raincloud, your neighborhood weatherman. Hi there, boys and girls. It's Mr. Dodgers here.
Thanks to ACM for a very informative and entertaining commercial there for us, and for being a great sponsor of this event. Just a few housekeeping things. This is on Adobe Connect. There's many platforms being used and on this event in order to provide the best technology for each unique session. In this session, we'll be using Adobe Connect platform. All attendees' lines will be muted upon entry. Attendees may participate in the session by using the Q&A box. And should you need any help at all connecting, or you having any issues, feel free to call Randy Hertzberg at the cell number you see on the screen, 443-996-0783, or her email at rhertzberg@ncma.org. So feel free to call if you're having any connection issues. Also, to let you know, this session is being recorded, and by participating in this meeting, you are consenting to be recorded. And as always, in all of our meetings, we are operating under NCMA's antitrust policy, which can be found on the NCMA Midyear event website. All participants are expected to exhibit professional behavior in compliance with this policy, as well as NCMA's anti-harassment policy. As noted on this slide, please refrain, intervene, or disengage from any inappropriate discussion and report any concerns directly to the NCMA staff person. We also want to thank at this time our very generous sponsors for their support of this event. Without them, this would not be possible, whether in person or whether virtual. Please visit the NCMA Midyear event website to meet all of our event sponsors. Just as a brief overview of the meeting, what we'll be discussing this afternoon. We've got a lot to discuss, so I won't belabor it, but what you'll see here is a review of current committee activities. This will be an overview of what the Masonry Committee, Technical Committee, and Communications Subcommittee worked on since the last meeting. This review will also include the recommendations for actions that will be considered by the NCMA Board of Directors from this committee. LA Masonry, there'll be a presentation from Russ Peterson of Insultech of the new LA Masonry structural design software and what all it can do. Then there will be a presentation from Jeff Buckowitz of the NCAA on the new Masonry Design Web magazine. So we will now hear from the subcommittee chairman. At this time, I'd like to introduce Mr. Craig Wallach from ACM Chemistries, and he will report for the Masonry Technical Subcommittee.
Thank you, Gary. Welcome to everyone. We'll go over what we we're doing a lot at Masonry Technical. We'll go over some of the major items that we are doing. Including product category rules, and then as part of that, the environmental EPD calculator. Then we'll talk, related to that actually, is carbon sequestration. And last, we'll talk about fire safety. So with the EPD, if people know how all this works, right? So we more familiar with the EPD, the Environmental Product Declaration. It's sort of like your nutrition statement of how we affect the environment. So that all of the EPDs are done consistently, first thing you need is a product category rules. So the product category rules basically set the groundwork for what needs to be in the EPD and how you do it. The PCRs are renewed every 5 years. We did have one with ASTM that was just retiring, but ASTM got out of the PCR business. So we have contracted with Underwriters Laboratory, and we are just finishing up the new PCR. It's to bring it into compliance, similar to the old one, but it brings it into compliance with the new ISO standards, and add some other things like carbon, getting credit for carbon sequestration. A draft was prepared. It has just finished review, and I expect that this will be finished by the end of the year. So I'll be back on the street as a set of rules for doing your EPDs going forward. Related to that is the EPD calculator. We've always talked about there's a lot of information that goes in the EPD, and if we could have a calculator that had some default values in it for electricity use and other things, you know, based regionally, you could use those as defaults and then put in other values if you had better values than that. What we're looking at right now is that the Global Cement and Concrete Association in Europe is developing a EPD calculator for regular concrete. Okay, they're now talking to also get some data in from the United States and stuff that we could use from dry cast. So we're going to let them finish their effort, and then we're going to look at it and see if that would be useful for us. We don't know exactly what the model would be. It may be a subscription model on their base, maybe something where NCMA could join it, and then all the members could use it. So that's coming down the pipe. So related to that is carbon sequestration, and that was added to the PCR. So with carbon sequestration, we know that, you know, certain amount of carbon dioxide is liberated when we make cement, and that's, you know, has given, we make cement and then use it in our products. So that has been a negative. But we also know that concrete absorbs carbon dioxide, reabsorbs it back out of the atmosphere. And some recent research that we're doing shows that concrete masonry actually takes a fair amount of carbon out of the atmosphere, and fairly quickly compared to regular concrete. And that's really due to the porosity of our material. So we have set up a task group. We're developing a testing protocol right now using a procedure called TGA, thermal gravimetric analysis. Some preliminary work's being done right now to set up how to do that testing. And then we're also have requested samples from members to do some pilot testing once we get that, to see how consistent it is and what other variables affect it. So this is in the early stages, but it's actually, some of the initial results are very encouraging and exciting. We look forward to getting more information on that. The last area of focus that we have is the area of fire safety. Now, as most people know, for concrete masonry, we get fire ratings, right? And the fire ratings are based on, the system we have is over 30 years old, and it's basically based on the equivalent thickness of your block, right? So how hollow is it? You know, you got your block. Most block are what, 48 to 50, 52% solid. So if you squeeze it down, what's the equivalent thickness, and then also what aggregates you use. So you get different credit for different aggregates. Lightweight aggregates give you more fire resistance. Anyhow, we can calculate, that's how we calculate fire ratings now. All the research and all that is based on our standard 3-web CMU, right? 3 webs going across full height, and also with the aggregates that we had looked at years ago. We get a new aggregate now, we can't really give it a fire rating because it's not in the table, unless we assume that it's the worst kind of aggregate, okay? So what we're doing is a couple things to see if we can upgrade fire ratings to address newer configurations, like new block with reduced webs or H block or something with only 1 web, right? And then also new aggregates. So new block that have smaller webs or reduced webs don't have the same equivalent thickness, but we think it still gives you good fire rating. Really what happens when you hit the fire, the front edge gets hot, then the air in the core heats up, and that's what transfers it to the back. It really doesn't go through the webs. So we said, let's look at all the test data that we had. The Western Kentucky University is taking all of our historical test data, over 100 fire tests. That was what the current fire ratings are based on, and they're re-looking at it and see if they can get other correlations and other regressions that work, like looking at, can we just look at face shell thickness and maybe the density of the CMU. So based on that, they're going to look at that and see, can we get more bang for our buck that would also give us some good credit for some of the new innovative CMU coming down the line. So that's number one, that's going on. And second is large-scale fire testing. So to verify this, to do more fire tests with newer block and stuff like that, to verify what we get as a new model, we're doing fire tests both at the Canadian Research and down in Brazilian University. Unfortunately, that has all been delayed because of COVID. That was just getting started up, so that's going to be delayed about a year. We expect to get some results from this next year from the modeling, and then to get some fire tests maybe the end of next year. So after that, we'll start getting some ideas where we can go. So that's basically what we have for the big initiatives on the technical side, and that concludes my report. So now let's hear from Kevin Cavanaugh. Kevin is a consultant, represent COSA Lightweight and CFI Foam, and is the chair of the Masonry Communications Subcommittee. Kevin?
Thanks, Gary. Appreciate that introduction. And I want to say good morning to those of you on the West Coast. Good afternoon to those of you on the East Coast. Appreciate the opportunity to share with you today what the Masonry Communication Subcommittee, the meetings we had a few weeks ago now, prior to Midyear. And it would be great if next year we can all meet in person here in Milwaukee. I'm based in Milwaukee. Craig Wallach grew up in Milwaukee. It's a great place to be in the summer. And for those of you with warm weather, it's nice and cool here today. So let's move on. And I'm not sure if I'm controlling the slides or not. So let's see. Here we go. So we're going to cover 4 different main areas, including tech notes. They're being updated and we're modifying and improving the figures and drawings, some industry partnerships, software promotion, and Masonry Design Magazine collaboration. That's really the 4 main items that we've discussed in the committee. The last 2 there will be presentations by 2 other speakers. So I'm going to cover them quickly. But in terms of the TechNote modernization, a few years ago, everybody realizes that we updated the website, NCMA's website, and as part of that effort, we had to change the TechNote format and give us a little more flexibility. We're going to now, so that effort was completed, and we're now going to take a deeper dive, like version 2 of reformatting the TechNote. So that will include a couple things. Combining similar subject matter into one location or one tech note rather than having multiple locations on any particular technical subject. And then we're going to update the figures and modernize them, make them 3D, a little more easy to use and download for designers. So the first one that's in progress right now is on crack control. I think there's a Google group review where you can provide input on that. And there's going to be 4 others done throughout the balance of 2020. So if you're on those review groups, be on the lookout for that. But the net effect is the text will be reformatted. They'll be more user-friendly for architects, designers, which we want to be the case for folks designing with our product. Next item is industry partnerships. There's 3 main ones. There's FLASH, which is the Federal Alliance for Safe Homes. That's an effort down in Florida where the use of CMU in homes, in particular, to be resistant to hurricanes. That effort pretty much is on hold because of COVID-19, but it's kind of ironic and timely that we now have the hurricane coming up the East Coast. This would play in very well with the resiliency presentation. If you were sat in on the town hall earlier, the one speaker there talked about that quite a lot. The other partnerships we have is Build with Strength with National Ready Mix Concrete Association. That is an effort to get our product included with their efforts. There's a very technical approach, building code approach, durability, resilience, fire safety, disaster resilience, etc. And then finally, Shaped by Concrete is an effort by the Portland Cement Association, and that's more of a visual and aesthetic type of approach, design approach of what concrete and masonry buildings can look like. In terms of software, we have 2 software platforms that we've been promoting. Most everyone is familiar or should be familiar with Direct Design because that's one we've been pushing for quite a couple of years now. And that software is designed and used to design an entire building. The next one that we're going to introduce here shortly with Russ Peterson is Ella Masonry, and that allows you to design portions or elements of a building in masonry. So you may have a typical strip shopping center type of scenario where maybe the sidewalls or the rear wall is block and the balance of the building is something else. Ella Masonry will work very well for that. I'm maybe condense that a little too quick. Russ, feel free to correct me when you make your presentation here shortly. And then finally, the last item, and this was an action item or a recommendation from the subcommittee to the main committee to reallocate some funds that we had set aside for a FLASH, I believe it was, for one of the other partnerships, but to support this new online masonry design magazine that Mason Contractors Association of America is spearheading, and you'll see another presentation on that here very shortly. And that basically concludes what the Masonry Subcommittee on Communication has been doing, and I'm going to turn it back over to Gary Hensley at this point, and again look forward to seeing everyone up here in Milwaukee next summer. Thank you.
Thank you so much, Kevin. As everyone can see, our subcommittees have been doing some incredible work for the industry, and so we want to thank them for all of their hard work, for sure. I want to discuss now this new element design software with Russ Peterson from Insultech. Let me tell you a little bit about Russ. Most folks know his name. For those new ones here, we're going to give you a bio on him. But Russ Peterson is an engineer, a software developer, an active member of the Masonry Society. His company, Insultech, has created direct design software and other structural design software packages. He has participated in the development of various TMS design guides and other publications, and holds an MS and a DS degrees in civil engineering from Montana State University. So let's hear from Russ now.
Hello, everyone, and thank you for your time. This is going to be a short overview of the new Masonry software from NCMA. A little bit later, we're going to dig in and actually demo the software, but we're going to start early on here by just discussing how this software package fits into the overall world of Masonry software and what the differences are from another package that you may have been hearing about lately. So, Masonry. This is software for engineers. It's for the engineering design of individual masonry components. That means individual walls, lintels, columns, and pilasters. And you can basically think of this as a replacement for NCMA's old software, which was called either SMDS or CMS 10. Some of the differences are support for the latest building code. So for TMS 402, the masonry code, that's the 2016 edition. And also IBC 2018 support goes hand in hand with that. It's got a more modern interface. It has more detailed calculations output. And there are some other things that you'll see a little bit later on when we get into the actual demo. And beyond that, the big question that might be on your mind, if you've been hearing stuff coming out of NCMA for a while, is how does this relate to direct design? Because a lot of the messaging lately has revolved around direct design. That's the kind of up-and-coming software package. So how does this differ from that, and why do we need both packages? We're going to dig into that a little bit here. And I'm going to start off by showing a slide that we often show when presenting direct design. We talk about how at the start of a building process, you have a building owner, and he's got his vision in mind for the building, and at some point he gets the engineer involved. And engineers do these things. Engineers do a lot of things, but if we were going to simplify it a little bit, we could say that engineers do these four things. They calculate loads on the building, they do analysis, they do design checks, and then they get involved with drafting or creating drawings. And when all that's finished, you've got a set of plans that you can hand off to for construction or for an estimate, whatever you need. Now with these four steps, most of the time, the different steps are done with different approaches. So loads might be calculated with one software program. They might have a spreadsheet for that. Some people might still do it by hand. Analysis, that's almost always done with one computer program or another. Design checks might again be done with some software. They might be done with a spreadsheet. Some engineers might still be using pencil and paper for these things. And same story with drafting or drawings. You have different options. The big selling point for direct design is that it does all of these things in one shot. Okay, so there's no need to jump between different programs, spreadsheets for some things, transferring numbers between different tools. All of that is tedious and time consuming. Direct design does all of it in one shot. Masonry, however, doesn't do all these things. It just focuses on the design checks, the checks out of the TMS 402 code. I'm going to show the same thing in another way. So once again, we've got four steps. Okay, engineers do loads, analysis, design, and drawings. Direct design handles all of these things, the entire process from start to finish. Masonry only focuses on the third step, which is doing the design checks. The important thing to realize here is that those other three steps are not masonry specific. These are things that you do pretty much the same way for any building, regardless of whether it's masonry or not. So for example, step one, where we're talking about loads, one of the things you do there is determine the wind load on the building. The wind blows on the building, you get wind pressure. How strong is that pressure? It doesn't matter if the building's masonry or wood or steel or anything else. That calculation is pretty much the same. So that's not a masonry specific calculation. Whereas this step 3 I've got here, the design code checks, is very specific to masonry. We get into the nuts and bolts of the code, the TMS 402 code that the Masonry Society publishes, and it's highly focused just on these masonry specific aspects. So that's the distinction. And now we'll talk about why. Why do we need one software that does everything and one that just focuses on masonry? Why would direct design do all these extra steps? And the answer, we touched on this earlier, is that doing all these steps in one software package really saves time versus jumping around and using different methods for different steps. So when you can do that, you can make the building design faster, you can get estimates faster, everything is very streamlined for the engineer. And this really makes masonry more attractive and competitive because you've taken this engineering phase that has to happen when you have a new building, and you've made it very quick and easy. And the last bullet point I've got here, in some ways, is the most important and tells a real story. We do this because other systems do this. Other materials and building systems have some approach. It's not always software, but they have some approach that makes the entire engineering process easy. The best example I can think of is the metal building people. They will show up, they have the entire design done, they have drawings for you, they've calculated all the loads, everything else, and really all the engineer of record has to do is design the foundation, the concrete foundation. So they've made it very, very easy. And when other systems are doing this, essentially you just have to keep up. Otherwise, masonry is at a disadvantage because the engineering becomes relatively more difficult versus other alternatives. So that's the argument for direct design. Now, elemasonry just does the masonry design. If it's so good to do the entire process, why would we have a program to just do one step? And the fact is that sometimes engineers want the flexibility to do all the steps how they want to do it. They have other tools that they use for other steps. Maybe they have a software program to calculate wind loads that they use for every building they do, regardless of whether it's masonry or not. And as much as we're working on convincing them to use direct design where it's applicable, there are going to be some situations where they're just not going to do that. They're going to use different tools for different steps, and what they really want from us is a good, solid masonry tool to give them good, efficient designs so we can get them away from just kind of blindly specifying more steel in the wall than what they really need. Another reason is that direct design won't handle all buildings. You can get some more exotic architecture in there, like curved walls, for example. Those kinds of things just can't be modeled in direct design right now. We're continuing to work on the program. We're making it more flexible so we can handle some of those things in the future. But right now, there are some types of structures where you can't use direct design, so you will need to fall back to an older approach and use elemasonry for your code checks. And in a similar vein, direct design is only for all masonry buildings. Okay, we do have a lot of structures that have masonry, but they're more hybrid, where you have other materials also. So, for example, a wood building where you have a masonry elevator core, or any kind of structure where they're using masonry for the shear walls, but not for everything else. Direct design is not a good fit for those situations. So we need a tool like elemasonry to give engineers a good solid option for masonry used in isolation like that. And the last point we list here is, this is kind of similar to the last slide, we need to keep up with other industries. As much as they have these full life cycle tools coming out and approaches, they still have individual component design software to give engineers a good option for just designing a single component of whatever the material is. So we need to make sure we're keeping up with the competition, essentially. Okay, so having given that little look at how this software sort of fits into the grand scheme of things, now we will move on and give a little demo of it. This is what elemasonry looks like when you run it. You can see here on the home screen we have an area here in the upper left where you can create new components. You can create walls, beams, pilasters, or columns. You have an area here in the lower right where you can set some common criteria, like what building code you want to use. So in this case, we're going to leave it at the latest 2016 version of the building code. You can set things like the F-frame M value, the steel yield value, etc. Then over here on the right, you can see the list of all of the components you have created in this particular file. So we can store several components in one file. And in this case, I have pre-populated this with some sample components. And we will take a quick look at each component type just to see what it looks like and give you a general feel for how the software works without getting too much into the details. So let's jump into a wall design here. You can see we've got a drawing of the wall here, and it shows everything detailed with the bars laid out as you might actually detail them in a practical situation without merely saying number 5 is a 48, for example. You can see here from the shading that the program handles partial grouted walls. We can also handle fully grouted walls. There's a setting for that. We can also switch from running bond to stack bond. So handles those kinds of common situations. I could change from an 8-inch CMU to a thicker block if I wanted to. Can adjust the height and the weight, length of the wall, etc. Different bar sizes. I can have 2 curtains of bars if we wanted to. Different settings like that. And you can also have 2 bars in your horizontal bond beams. You can also switch away from bond beams completely and choose joint reinforcement instead if you wanted to. So lots of flexibility here. On the right hand side, all these green check marks you see are the summaries of the code checks. So if we were to fail one of these, it would turn red. I'll kick the wall height up quite a bit to where we're likely to get a failure, and you'll see the calculations go, and sure enough you can see one of these has turned red because it's no longer strong enough with the wall 20 feet high. So in addition to those input options, there are a lot of calculations you can look through. I'm not going to go into these because these are really the domain of the engineer and really getting into the weeds of the code provisions, but you can see here that there are an awful lot of things that are displayed for the engineer to make sure he's comfortable with the design. Also, this module does both in-plane and out-of-plane behavior in walls. So formerly, you would see, for example, a shear wall module and a bearing wall module separately. We now have the convenience of having just one wall module that checks everything. All right, so that's a quick look at walls, and we can jump into beam design here. So this would typically be a lintel over a wall, a lintel over an opening. Again, we have a number of options here. You can indicate that you have stirrups. You can change up the flexural reinforcement, change the block size, etc. Different options for loading, and much as with the wall module, it goes through all these calculations so the engineer can be confident that things are being done how he expects. And also, like the wall module and all the other modules, you can bring up a report here. In fact, I will jump back to the wall module real quick because I think it has the best one to demonstrate this. But the report that comes up has all the calculations that you've seen in these tabs here. So if you want to satisfy the building official that the calculations were done how the Masonry code says they're supposed to be done, that's very easy to do with the output from this program. Okay, we've seen walls, we've seen beams. Let's jump into the pilaster module. Okay, you can see it's a similar situation here. We can model a pilaster. We can put loads on it. We can come through and look at some of these calculations that are displayed by the program. Engineer can be confident that all these checks are being done in the way that he expects. And lastly, column design. Created a new one here. There we go. You can see checks again on the right. All these green check marks mean that everything is passing. And much like the other modules, we can jump through these calculations here and verify that everything was done according to code. And I think we're just about out of time here. So we'll conclude the demo, and I think there will now be some questions if we have time.
Hey, Gary, are you there?
Can you hear me now?
Yes, we can hear you now.
Oh, okay, I apologize. Russ, thank you for that presentation and that online demo. I'm sure everybody had those formulas figured out by the time Russ got through scrolling. Tremendous work there for the industry. I want to remind everybody that you can put questions, and we're running right on schedule actually. So feel free to put questions in the question box to your right, and for any of the speakers, for Russ, for the upcoming speaker, and or Craig or Kevin, either one. And we'll go over those at the end, one by one as we can. So, all right, to the next topic.
Hey, Gary.
Introduce. Yes.
I think we might have time
Nick?
for one or two questions for Russ if you want to, do we want to go over those
Sure.
now?
Yeah, let's
Okay,
go
Russ,
over,
we have
go
you
ahead
on the
and go over
line,
Russ's.
right?
You do. Can you hear me?
Yes, we can. So we did get a couple of questions come in. I'll go ahead and read them, Gary, if that's okay with you.
Sure, yes.
So one question was, does the program allow design by both allowable strength or allowable stress and the strength design method?
It does, yes. As engineers, the code gives us two options, two design methodologies we can use, and in this case, this program will support both of them.
Great. Another question was, can Masonry, or maybe even direct design for that matter, either now or in the future also calculate wall assembly thermal properties like U factors and heat capacities, or is it simply structural?
Just structural at this point. We have kicked around doing that in direct design because it does have more of the building envelope versus just one wall at a time, but so far it's not really on the official development schedule.
Okay, and then the third question is that, and I may be able to kind of help to hint a little bit, was on what the cost of the software will be and other levels or options. We haven't finalized some of that stuff yet. My guess is it's going to be in the neighborhood of $300 to $350 per license on an annual basis. It'll be a subscription-based software. But Russ, are there any other add-on options or levels of the software?
Not at present. We just keep it simple, and there's just the one version.
All right, great. Gary, I think that covers the questions for now. Like you said, if there are others that come up, we can get back to them if we have time at the end, but I'll turn it back over to you.
All right, thank you very much, Nick. And Russ, again, tremendous work for the industry. On to the next topic, I'd like to present Jeff Buckowitz from the MCAA. Jeff is the current president of the Masonry Contractors Association of America and the Masonry Foundation. Jeff started his career in the masonry field in 1998 as the director of marketing for the MCAA. In 2005, Jeff went on to lead Building Stone Institute as their executive vice president for 2 years. In 2007, Jeff returned to the MCAA in his current position. In 2009, he helped form what is known today as the Masonry Foundation. Jeff also serves on the Natural Stone Council Board and is part of the steering committee for the CISC, the Construction Industry Safety Coalition. So, Jeff, take it away. We're excited to see what the MCAA has been doing here.
Great. I appreciate it, and good afternoon to everybody. Just wanted to go real quick. We're going to be talking about masonry design and our transformation. Probably about 12 months ago, we decided that the direction for the architects in particular for publications was going to be changing. That had a lot to do with our agreement that we've had with the AA student group, where they have said they don't take any paper magazines. They don't even send out their own paper magazine. Everything's done digitally through them. And then as we continued to publish masonry design, we'd get probably 2 or 3 notes every time we published one of the magazines that, hey, we don't like these. We don't like you wasting the paper. We'd like to see it in a different format. So we knew the time was going to come, or we'd have to transition into a digital format. And we didn't want to just migrate to a flip book and call it a digital publication. So we've created something that we just rolled out in June. It's a very soft rollout right now. We're not heavily promoting it because we're still making changes and additions as we continue by here. And we're going to take you on a quick little demo of what there is there for the design community and why it's special and why it's a little different. The one thing we have in here, we call them simulators, and our simulators have a lot to do with being in the virtual world and dealing with the virtual reality. You're seeing over here there's a download section where they'll be able to go in and download these different simulators to a VR headset, and they'll be able to actually experience masonry in the virtual world. So we wanted to make it very immersive for them. So we developed these components, which we think will engage the architectural community, particularly the young folks involved in it. And you'll be surprised, I think there's a good number of folks that'll give it a good try. So first, we'll start with the physics simulator. We'll go over here into this section, and we'll show you a video that we've prepared for it. And this physics simulator, it's nice that it comes off the back end of the other presentation because it actually simulates object fracturing. And we'll show what happens as these wrecking balls come through and try to knock these different wall types down. It's a fun thing for us to do. It's not going to show the exact precise elements to it, but it will show it in ratio. It will show the fracturing, though, of the material as the ball came through. You saw that we had to increase the size of that ball in order to get through that particular thing. We can also add wind speed to knock over the different walls, and we can adjust the different wind speeds to show how the different walls will perform. So you can see that wood flew out pretty quickly. And now, of course, the masonry wall takes quite a bit longer. You have to get to some severe wind speeds in order to see any type of destruction of those walls. So it's more of a fun thing. It's nothing in there is the exact sciences just yet or been completely calculated according to all those physics just yet. And we want to do it more as a proportional representation of how different materials would perform. So we'll go from the physics simulator and we'll show you a component here, the virtual wall building. This is one that we like a lot as well. This will be in what we call our sandbox. So the architects will go, they'll be able to have a design blueprint that they'll actually be able to look at, a wall design, and then they'll be able to work within the sandbox. And this is actually being done by the person working with the gloves. They actually have a headset on, and they're actually doing all the lifting. They're doing the mortar spreading, and they're basically building that wall that was in the design. The materials are all there for them. We can adapt this. We can build any type of a wall. We can add an arch if we wanted to, and we can have them build an arch. We can have them do a variety of different blueprints, and they can select one and go in and actually build small projects, which we thought was pretty important to get them working with a hands-on feel with the different materials. The nice thing about this is if they use it in college, in a college environment, if they don't have a big lab where they have the ability to actually bring the materials in and get a little messy with our materials, they can actually do it virtually, and they can experience it with these virtual headsets. So that is our virtual wall building process. And I'm going to bring you now into something a little different, and this is going into our 360-degree case studies, we call them. And I'll tell you a little bit about these. And what we're doing here is we've done this. This is the Getty Museum in California. We got the opportunity to go out there and do a 360 view of their structure from the outside. That's a dollhouse version, so you kind of get an overview. But we'll go on into the building itself. and we'll take a look around. So as a case study, you can find these little blue dots, and you can actually click on those, and it'll tell you what the material is. And that joint, we just had a sample that was a spec mix mortar joint material they may have used. You can do the blue dot on the material itself and tell them what type of material it is. And you can do a variety of different things within this case study. So what we're doing is we're taking that flat page that you would get in a magazine, and we're making it a live version where they can actually, it's experiential for them, and they can actually go in and they can see different beautiful masonry pieces and actually walk around them and visit within them, and that will engage them a little more and take them on a different way of viewing a case study. Something we're working on right now, and we're going to go into that next here, is we're going to go into what we call, it's our drone footage. So our drone right now is out in New Mexico getting ready to film our first project, and that's some canyons out there that are all masonry. They're gorgeous canyons, and a cathedral out there too. The concept is to bring in the three-dimensional model and the actual structure. So if in this case, if it was a cathedral, we'd be doing all the photogrammetry of the cathedral itself from the outside, from the exterior, and eventually you'd be able to experience it on the inside as well, in the interior, through the three-dimensional and 360 camera work. We're pretty excited about this because this is going to add a whole new component to it, and we're going to be able to visit the structure inside and out, and it'll add yet a whole nother experience for folks. I think we lost our screen momentarily. We'll be right back in a moment here. Oh, jumping ahead on me. Okay. So that's our 3D and our drone. Those are the experiential sides of the site. So those will be coming. The 360, we already have the Getty up there, and we have another some footage of the French Lick Hotel out there too. So that's up there as well. Not sure where our screen will be up in a moment. I lost you. Okay. I have somebody navigating for me. All right. And it's back up. Yep, we'll go on and off to the telehandler. So another simulator that we do have in here and that we're pretty excited about is the telehandler simulator. This one, we want the architects to have fun, be able to experience actually driving a lift and a telehandler. But what we also want this side of it, and there's a component of this whole virtual reality that we want to use for workforce development. So we see this being a bigger side over there for us, where we'll actually be able to have students at a career fair actually try their hand at working a telehandler or using the virtual wall simulator, all the different components of the VR. So there's a nice place for all this in the workforce development side. We also have several books that we credential mason contractors. We credential their lift drivers and give them the credentials they need for OSHA. And we're looking at actually converting those books and to try to gamify that experience for them that would allow them to get credit and to be OSHA credentialed by simply doing it through a virtual reality. That we think they'll have a better time going through that than they would reading a book and actually taking a pretty lengthy test. They'll actually be able to demonstrate that they understand what they're doing with the lift. And then the part that we're pretty excited about is some new technology that just recently came out, literally probably about a month ago, and it's called the YOW chair. It's a VR chair, and we're going there now for you. And this chair, you may have seen these simulators at trade shows and those types of things, where you're actually in a virtual world and you're in a chair that actually moves you and actually is all synced to your screen on the inside. So that's what's coming next. We're hoping to have this by the fall of next year, and they've made it very economical to get these virtual experiences. That chair itself right now runs for about $1,500 just for the chair, but you do have the experience of actually driving and moving around in whatever vehicle you might be. It has to be programmed to sync with your VR headset. But as you can see, there are gear shifts, there's wheels you can use and you can add in. And what used to be a $15,000 to $20,000 experience or setup is now something that'll probably cost you around $5,000 by the time you get the headset, a computer system to run it, and the pod itself. Our goal for this for workforce will be to have several of these available for shipping, and then as local and state groups have career fairs or have different things that they'll be utilizing them for, they would just call us and have us ship them. We'd book them for them, and we'd ship them out, and they would, of course, learn in advance how to prepare and use those. So that's what we have on the VR front, and that's what we have on our masonry design experiential transition for our magazine. And I'll leave it open for questions.
Please feel free to ask Jeff any questions. We have a few minutes here as we go through this. I will say what they've accomplished here through this. The future is here. I'm telling you, I didn't think I'd ever see in my career such virtual tools that we can use, but it's really, really amazing what's been accomplished through the work for masonry design. So Jeff, incredible, incredible work.
Thanks, Gary. Yeah.
So it does look like, so I think we have one question that came in so far, and that was, what are the plans for kind of promoting to the target audience in the future? I know the website's out there, but what are the plans to try to get it to those target markets that you're looking at for the future?
Sure. So basically what we're doing is we have a pretty robust list of contacts in the architectural community. We have over 15,000 addresses. They all will eventually receive a postcard once we do our harder rollout, telling them and making the announcement of the transition. So that'll happen through regular mail, through a postcard, but we'll be on social media quite a bit, letting them know what's happening. We'll be doing e-blast. We're doing all sorts of marketing efforts, and we have quite a few email addresses of the design community. So a lot of that will be done directly. The one thing we really didn't touch on is we will still have, as part of the masonry design, there will be regular features that will be changing at least 4 or 5 times a month. We'll be adding features to it and bringing new technology into it. So we're pretty excited about really getting to that harder launch time.
Great. I'm not sure I see any other questions at the moment, Gary.
All right. Well, thanks again, Jeff. And as we're starting to wrap up here just a bit, I want to thank especially our speakers, Russ and Jeff, for being with us in our subcommittee meeting leads. It is again amazing if we look at the world and our world in masonry from a year ago. It has been it's remarkable changes going on throughout this year. So again, thank you for all the innovative work that's going on. And please take the poll that you're given before you leave this session. The feedback on this is very important. I know this is a very unusual format for us to be conducting a mid-year meeting, but it's been so far very productive and well received, but we do need your feedback off of this. Also want to point to what's next up. Coming up is the SRW and Hardscape's current initiatives. That's from 2 o'clock to 3 o'clock. And then Selling During COVID, the Good, the Bad, the Ugly, which is hosted by the Young Professionals Group. And then tonight, don't forget the social events tonight and the session tomorrow, the Social Network Hour at the Golden Garlic Competition. Donna and Dean and Rocky are cooking with garlic. So, and Social Networking Hour, barbershopping with Bob and Terry. You don't want to miss that. All right. And right after this meeting, we have the following sessions. And also don't forget the social events tonight that we just before mentioned. Tomorrow on the Masonry segment on the future initiatives, They're also going to have Joyce Owens here after we review the strategic plan review. And then Joyce Owens, an architect, tremendous work that her company has done, her firm has done, and it's why I use Masonry. She really focuses on Masonry. You'll want to see that. It'll help you in your market. And then the open forum, participate in an open exchange among members to ask questions or make comments. So unless Nick, do you have any more questions that have popped up on the board at this point?
Gary, I have not. Certainly, if there's any other questions, we're happy to address them, or we can address them tomorrow as well on anything we talked about here or anything that we'll talk about tomorrow.
All right. Well, I think, and very unusual if I'm conducting over a meeting to end 3 minutes early, but that's what it looked like we're going to do unless anyone has any more questions or any other further comments. So again, thank you for joining us. Thanks to our speakers, and we look forward to seeing you in other sessions throughout the day and tomorrow.